Another form of renewable energy is hydroelectrical energy, which is utilizing the power of hydrology to create movement through the water and store electrical energy. And so the utilization of hydrology has been around for centuries. It was first used by the Greeks in 146 BC, where they used a water wheel to turn flour into wheat. And then the Han Dynasty used it in about 200 BC, where they used water wheels to break up ore, grains, and it was even used for early paper making. So some of the milestones in the advancement of hydrological energy. In 1831, the first hydro generator was created, and that was by Michael Faraday. And by 1849, James B. Francis created the Francis turbine, which was a very foundational blueprint and generator that is still of some sort used today. At 1878, the generation of hydroelectric energy was created, so then we're able to better store this energy and use it for future uses. And in 1882, Appleton, Wisconsin created the first hydropower plant. And in 1920, hydroelectrical energy produces about 25% of the U.S.'s electrical generation. And by about 1980, the capacity to store that energy for future use about tripled since the 1920s. So, hydroelectrical energy is produced by harnessing the movement of water to convert mechanical energy into electrical energy. It is very hydrological dependent, and so is located with areas with large available water sources, such as rivers, large streams, or oceanic access, and is usually created near bodies of water with a decreasing elevation, so it goes from a high to low elevation, and it, depending on the community that's specifically involved, it is very time dependent, money oriented, and there's some spatial limitations that might be an obstacle to create a hydroelectrical energy plant. So some of the plants that you can create, that you can have, or that are there, is the run-of-river, which uses the natural flow of water to generate power through the turbines. So the water that is moved through the river turns the turbines and is able to generate that electricity. There's also storage hydroelectrical energy plants, which is like a dam, and it releases water from a high elevation to a low elevation. And as that water falls, the gravitational forces help turn those turbines. And then the pump storage is the same thing as a dam, but water is pumped from a low elevation to high and is then released. And then another form of energy plant is the offshores, but that is not as advanced, but it's starting to progress through time, but it captures the tidal and wave movement to generate electricity from the salt water. So about 71% of the Earth's renewable energy is produced from hydropower, and that's roughly about 7% of the nation's just overall electricity. And so hydroelectrical energy, it creates a lot of jobs, and so it supports more than 143,000 jobs currently, such as engineering, manufacturing, operations, maintenance, construction, and so it's very good for the economy. Overall, though, the nation, China, is the largest producer of hydroelectrical energy, and followed by that is Canada, Brazil, and the United States. So some of the advantages to having a hydroelectrical energy plant is there's very minimal pollution, it strengthens the economy, there's not very much maintenance and operation costs, and it utilizes the abundant resources of water that can be found in areas everywhere. It can change reservoir or stream water quality, which is also a disadvantage, and it can harm the surrounding wildlife and fish habitats, but can also be very precipitation dependent, and so without rain it would be hard to have. There's many untapped resources around the world that you can that can still be utilized, and as we're starting to involve multiple stakeholders, they're starting to integrate the social, economical, and environmental factors that go into it. And so in the future, we can see reduced costs and reduced greenhouse gases and increased proficiency with the use of hydroelectrical power. Thank you.